In this video, I will be going to explain you runnable sequence. It is one of the primitive runnables which I discussed in the last video. So what this runnable sequence do? It is used to connect two or more runnables sequentially. For example, you have a prompt object which is a runnable because it is from the prompt template class, and then you have a LLM object which is from the chat OpenAI class. So these kind of things you have already seen, that prompt template class and chat OpenAI class. I have told you that they are inheriting the runnable class. That is why the object of those classes are runnables. So what happens is, in runnable sequence you are connecting these two runnables or more runnables. So after that you may have parser also. Let's say this is runnable 3. So you can connect two runnables or more than two runnables sequentially using the runnable sequence. So to connect them sequentially, you have to write runnable sequence prompt comma LLM, or if you have multiple, then you can also put comma parser as well. So prompt comma LLM comma parser, like this you can connect all these runnables and form a chain, which is a sequential chain. And what happens is, the output of this runnable will be the input to the another runnable. So this is the output from the prompt that will become the input to the LLM, and the output of the LLM will become the input to the parser. So it will be like this. So this is what I have written also. When you connect two or more runnables, it will form a chain, and the output of the first runnable becomes input to the second runnable, and there is no restriction on number of runnables to be added in a chain. So you can add n number of runnable in the runnable sequence. So after understanding this concept, you will be thinking this kind of thing you have already seen when I explained you briefly the chain concept, where I did prompt, I put a pipe sign, then I did LLM, then I put a pipe sign, and then I put parser. So this kind of chain I have already shown you. So basically this pipe symbol is LangChain expression language. It is the alternative method of creating runnable sequence. You see, what happens is, runnable sequence is used the most as compared to another runnable primitives like runnable lambda, runnable parallel, runnable pass through, etc. So because it is used the most, so one alternative way is created, which is a pipe symbol. So what you can do, instead of writing chain equal to runnable sequence, runnable 1, comma runnable 2, comma runnable 3, comma runnable 4, what you can do, you can write simply R1 separated by a pipe sign, R2 separated by a pipe sign, R3 separated by a pipe sign, R4 separated by a pipe sign, like this. So this alternate way is LCEL, LangChain Expression Language. So right now, only for runnable sequence, they have created the pipe symbol. Maybe in future, they may create similar kind of symbols for runnable parallel or other primitive runnables. But right now, we have only pipe symbol for runnable sequence. So you see, this kind of program I have already shown you when I showed you string output parser. So I will modify the same program a little bit and show you using runnable sequence. So I will not use the pipe symbols. Instead, I will use the runnable sequence class. And you see, this class is present under LangChain underscore core dot runnable. So within LangChain underscore core dot runnables, I will import runnable sequence, and then I will not use the pipe symbol. What I will do, I will use this class, which is runnable sequence class, Rest of the code will remain the same, and by using this I will still form a sequential chain. So now I will show you the practical of this. So you see this string output parser, I have already shown you where I created the chain, where I don't need to use invoke again and again. I created the chain where the output of this template becomes the input of LLM, and the output of LLM will become the input to the parser. So what I do, I copy the whole code and paste it in the runnable sequence.py. So I paste this, and here you see I will comment it out, and what I will do here, I will write from LangChain underscore code dot runnables. I will import runnable sequence. After this, I am here creating a chain. So here, instead of writing pipe symbol, I will write runnable sequence, and here I will write template, then comma LLM, then comma parser. So that's it. My chain is ready. So rest of the code will remain the same. So here I am doing load.env. It will load my OpenAI key, which is present in .env file. After that, I am creating the LLM object of chat OpenAI. Then this is the template which I am creating. What is the advantage of the topic? And the input variable is topic, and the parser is string output parser. So here, first I created the chain using runnable sequence. Then I'm passing the topic name is vegetarian diet, and capturing the data in the result and printing the result. So I just run this. So here you see this is the output which I have got of this particular topic. So this is all about runnable sequence.